Hi, IAM. My name is Chloe Curry and I am from Emerson Automation Solutions based here in Ireland. Welcome to today's Bitesize webinar on how to digitally transform field device commissioning and management. So, digital transformation is a hot topic in today's world, and in particular with demand increasing more and more. There's a lot more focus on asset uptime and ensuring downtime is kept to an absolute minimum, and plants are looking to solutions that can help with this. This is where we come into the idea of predictive maintenance. We're moving away from the concept of reacting to situations in real time and instead having analytics tell us that our pump, heat exchanger, air handling unit, whatever it might be, will run to failure in 3 months' time, giving us time to work around production and plan for maintenance. Go one step further, and we can not only track the health of our assets, but optimize our energy consumption as a result of this health. For example, tracking steam trap monitors or filing of heat exchangers and adapting maintenance to ensure we are hitting our targets. And I know this is also a topic of interest at the moment, particularly with the Institute of Asset Management, as their 2021 annual conference is centred around the climate emergency. So I'd like everyone to consider that this is not the first time that we've been through a mass digitization of processes in the process industry. Digital process control was not immediately comprised of the finely tuned machines that we've grown accustomed to. We got there by installing sensors to collect real-time data, and this is now a proven streamlined process that has created an immeasurable amount of value over the years. Like, you only have to think of the idea that process control has had a hand in producing the millions of COVID-19 vaccines that is allowing restrictions in some countries to lift very slowly. And I think this slide will resonate with a lot of you that are trying to focus more on reliability and maintenance. We have what we call a closed loop in our current production process control on site. So a sensor on, for example, a valve determines that the flow in a pipe is too low. Our process control loop sends an output to say open the valve a precise percentage and the flow is maintained at an accurate rate. We look to other areas of plant operations such as reliability, safety, energy, and we don't see these same closed loops. In fact, we see time-consuming manual processes along with siloed databases of information with cumbersome work order procedures. So this is what we say is called a frequently open loop. And if you don't believe that codified knowledge and real-time data can change your work practice, then you only have to think about ATMs, online banking, weather apps that are now so accurate that they can actually tell you down to the minute when it will start and stop raining in your location. Online sat navs that will reroute you around traffic jams, apps with nearby taxis, the list goes on and on. Digital transformation has been going on for years now. And with this digital transformation or Industry 4.0, some industries have their own take on it. For example, Pharma 4.0 in the pharmaceutical industry. Digital transformation closes this see, decide, act loop in these new areas. We have more sensors, and I always say we can't optimize or track what we don't measure in the first place. Pervasive sensing is becoming more and more commonplace. The expertise or decision making no longer has to be a week of research in contacting vendors to find root cause analysis. We can utilize machine learning and leverage data sets collected to determine patterns in our asset behavior. And the act element can be supplemented with prescribed actions that are provided to the technician or the engineer on the trigger of a certain event occurring. So all of this is centered around managing our field devices. So like I said, we can't track or baseline what we aren't measuring in the first place. And so today I'm going to go right to the beginning and talk about digitally transforming field device commissioning and management. So traditional instrumentation management means sending a technician out with a field communicator to configure and collect data from instruments and valves on a regular basis. And this is part of a reactive or a preventative maintenance program. Operations and maintenance personnel manually record details of the operations, which requires a lot of time, and 17% of the time it's not actually done. The data is never transcribed into their asset database. Therefore, the device configuration stays only on the communicator itself, and device diagnostics are then stranded in the devices. So why would we want to change the status quo? Well, a lot of the time we're actually doing work without it being needed. In fact, 60% of the time we do actions for the sheer fact that it's scheduled, not because there's an actual issue with the asset or device that we're looking at. And then, why expose our technicians out in the field? We could be using their knowledge to upskill them to analyze data instead of collecting it. And then why bother ourselves with alerts 3 months before the failure occurs? Why are they important? Well, studies actually show that the costs of repairing a field asset is 50% higher than if the issue would have been fixed before the failure occurred, not even to mention the associated costs of process downtime. So we want to change the status quo and move away from preventative maintenance to predictive maintenance. And what exactly is preventative maintenance or predictive diagnostics? Well, plant performance degrades over time, and an early warning device alert can identify issues to watch and then schedule for repair or replacement several weeks, even months prior to a device failing. This is then, if you contrast this with a preventative maintenance routine where during a planned shutdown, all assets are taken out of the line and checked to see if they even require maintenance. A lot of the time, this isn't even the case. And instruments, devices, assets are taken down with no action having even to be taken, wasting man hours and shutting down the plant for days, even weeks longer than necessary, having a direct negative impact on the output of the plant. And then if you contrast this again with a reactive maintenance routine where assets are run to complete failure and the maintenance routine involves calling in a technician at 2 a.m., for example, try and fix a pump. Say nothing can be done until the morning. When we contact the vendor can't get to site until a week's time. And then when they do, they tell you that the part you require has a lead time of 2 weeks. Sometimes the quickest solution is to just purchase a new asset to get production up and running again. And you can straight away see the savings in having a predictive maintenance routine in a case like this. So device alerts provide early warning, so you can take action before the safety of personnel and process uptime are impacted. In this particular software interface, we have online monitoring with good alarms, advisory alarms, maintenance required, and then field alarms. So you can see the progression of them. So why are alerts important? So they're important because they help us to prevent harm from happening or a safety incident, but also to help us decide when we have to take action or in fact when not to take action. And, an asset can generate a large number of alerts. So when we are looking at the overall plant, if we were to come in the morning and look at the overall health of our plant, what should we focus on? Should we focus on individual instrument and device alerts, or would you prefer to look at the overall instrument health? And this ties into a point that I made earlier, where often in order to determine the health of an asset, we have several silos of data that when you log in the morning, you'd maybe have to get 5 different pieces of information from 5 different places. So wouldn't it be so much better if we had a centralized database of information with an overall instrument health score? So just as an example, with Emerson's AMS Device View, our browser application that sits on top of AMS Device Manager, you get a welcome dashboard when you log in that gives you an immediate idea of the health of your plant and your assets. So for those unhealthy assets, you can drill down into each one of the assets themselves and check individual alerts. bring in prescriptive analytics into the picture as well. Oh, I need one. AMS device view will even indicate a possible cause and action to fix the issue. And being an HTML5 interface, it allows you to monitor your plant health remotely, which, given the current climate of the world, is a very welcome feature that makes working from home that little bit more connected to your site. So we looked at the unhealthy assets, but what about those unresponsive instruments? Where do we begin to look? Is it the control system? Is it the wirings or the instrument itself? So a top tip that I was always given as an engineer is start with the hardware, the wiring, and then check the software configuration. So where in the loop is the issue? Well, you can power the instrument directly from a handheld communicator such as the AMS Trex, and then help to diagnose the problem, simulate the instrument, and verify the host 420 milliamp readings to check the loop for wiring issues. Ideally, we would have all of our instruments online, but we don't live in an ideal world. So for those stranded devices, you can use a handheld communicator to collect the data. And what is really good about this particular example is you collect the data using the handheld communicator and then automatically sync it to your centralized database of information, AMS Device Manager in this case, which is Emerson's plant asset maintenance or management, application. So immediately we remove that issue of siloed information stranded on a device, and we maintain a centralized database of information with our device and instrument data. So traditional maintenance was done with a field communicator by doing an awful lot of prep work and following these above steps here once out in the field. Digital maintenance makes it so much easier. You search for your device tag, you do the changes, and then the changes are automatically documented, all online, time and date stamped with who did what and why. But what about commissioning? Well, traditionally, commissioning was done with a field communicator and walkie-talkies, extremely time-consuming. So a better way to do this is with bulk configuration, where you have instruments wired and configured in bulk. Better, but not perfect, with AMS Device Manager alongside. If any of you utilize or have heard of Delta V, you can eliminate all of this work by digitizing your commissioning, auto-sensing bulks of devices, automate the binding to the control modules, you have your automatic configuration and testing, and then auto-document everything in a report at the end, saving 90% of traditional commissioning time. And then what about wireless devices? Wireless technology is becoming more and more popular due to the monetary gain of having that lack of wiring. So we need to first get them connected to a host. Instead of going the traditional way with a standard field communicator, we can use the wireless provisioning app on the AMS Trex to provision your network up to 7 times faster. So use the latest digital technologies to monitor your asset health, device configuration and commissioning, and document everything digitally. Thank you so much for your attention today. If anyone has any questions at all, then please get in touch on the email or the phone number on the screen. I would be delighted to help you out. And thank you so much to the IAM for hosting this bite-sized webinar.